here's my cube, and when Jamal sliced it, I'm going to highlight here, that's his cross-section. If I were to draw that out, it's going to be a triangle. Because basically the plane he used of making that cross-section intersected 3 of the faces. Now, when we look at Jabari, he sliced his straight down. And you can see right here, it took off this rectangle. It went through 4 faces, so therefore it had 4 sides that made a rectangle. Okay? Alright, let's go on to the next page. That was quick, right? So a cross-section is the intersection of a solid and a plane. I've got this 3-dimensional shape, and then I'm going to take a 2-dimensional slice out of it. This is called a triangular prism. Prism takes a shape and kind of stretches it out. So here we had the base of the triangle, it's stretched out. If I were to make a cross-section that's parallel with the base, then it is going to be the same shape as the base. So here for the triangular prism, if I slice it parallel to the base, which is a triangle, I'm going to get a triangle. Now there are some great videos on Canvas to help you visualize this, and some are even kind of fun. You'll think they're pretty dorky, but I like them. So now what we're doing here, let's take a cube. We're going to take different cross sections and see what shapes do we get. Now a cube is basically a 3-dimensional square, right? So I have a square on all of the faces. So if I take, here I have a vertical cross section, straight up and down. What shape did I just make right there? Hopefully you're saying, Solberg, that is a square. Ding, 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 you are correct. Good job. Now let's go and look at another cross section. This time we're going to go vertical, but we're going to go through the diagonals. When we do this, will all of the sides be the same length? The answer is no. Therefore, we have a rectangle. Well, what if we do, I think it was Jabari who did this one. If I take off a corner, we kind of already talked about that. That's just going to be another rectangle. It's different than the one we just saw, but it's still a rectangle. Now, notice on part D, we are going at an angle now. We're not going straight up and down, or we're not horizontal. This is slicing through one of the vertices here, and it's coming down and out along the bottom base. What shape is that right here? Is that a rectangle? And the answer is no, because it's kind of coming at an angle. If I were to kind of pull this off to the side and look at it, it's going to look like that. What do we call that shape? That is a trapezoid. This would be a perfect time for the Star Wars meme. It's a trapezoid. Alright, okay, let's go. Next one, now we're going through 3 of the vertices. And that also intersects 3 of the faces. What does that make? It's called a triangle. Alright, now, how could you take a cross-section and make a hexagon? A hexagon is going to go through 6 of the sides. Is it possible for us to go through all 6 sides of a cube? Maybe you're like, I don't know, Solberg, that doesn't seem right. Well, it's possible. All you have to do is make sure you go through all of the planes, or all of the faces. So I'm going to start by coming down like this. We're going to go at such an angle that I'm going to come out the bottom right about here. Okay, so when I do that, it's going to come down to here and then down to there like that. Right here, we're going to come down to here, and then we're going to come down to here like that. And it's kind of hard to see. I maybe didn't draw this as well as I should have. Let me try that one more time real quick. So I'm cutting through here, through here, through here, and then it lands right there. So I'm going to draw this actually a little bit different. So this one comes to here. Alright. I basically screwed up that picture. I'm sorry. But the point is, you can draw it so it's going through, making a hexagon if it goes through all 6 of the faces, which is possible. Okay, so So let's keep going here. This next one is kind of a optional activity, but it's pretty cool. Let's pretend that you have this cylinder here, okay? And what we're going to do is fill it up with water. So this is all water. Now let's look at the shape that the water makes. If I hold it straight up, it's going to basically give us what a horizontal cross-section would look like, which is a circle. Now what if we tilt it about 45 degrees? Visualize here what the water does if I tip it 45 degrees, okay? And hopefully you're starting to see here that when you tip it, more of it, it's kind of going to look like that, right? Is that still a circle? Well, it's kind of stretched out now. We would call that an ellipse or an oval. Okay? Now, what's pretty cool here, this says till about 45 degrees, just before the water leaves the glass. Okay? So, if I were to do that, just before, so now it's like all the way on the edge here. Going to look something like that. Now what if it was contained and I did a little bit more? What we're starting to see here is that this is actually going to make a parabola. And I apologize, I am not an art teacher because I can make this look so much better if I was more artistic, but I hope you can visualize that when I held it like this, I made a circle. When I tilted it, it made an ellipse or a oval. And then if it goes all the way to the edge here, it's going to make a parabola. And if you're like saying, Solberg, I don't see it, just try this at home. Fill up a water bottle. I'm sure you have one that looks like that. And you can start to like tilt it until it makes those shapes. Now what if we switch it so we sitting on its edge like that? That's when it's going to make a rectangle. Hopefully you can see it there, okay? Alright. Let's jump down to a new shape, which we're going to call a cone. I actually want to tell you a story. There was one year where I had some teacher money left over, and so I went onto Amazon, and they said you could buy this giant cone for $72, which is about how much money I had left, that showed cross-section. So I was expecting this life-size cone like this tall, and instead I got this. $72 right here. Isn't that a shame? Alright, so here's my cone. A cone basically is a circle on one base and it comes up to a point here. Now we can take cross sections of this cone different ways. I could cut it horizontally like that, and what shape would I get? Hopefully right here you can see that is a circle. What if I go diagonally, but I don't go out the bottom? It's just going diagonally like that. Well, hopefully you can see the yellow part there is an ellipse. What if I do go out the bottom, or I go straight down but not through the tip of the cone? That's making a parabola. Now the one that you can't really see here, what if I do go straight down the cone through the tip? Well, then that would make a triangle. So you could get a whole bunch of different shapes depending on how you slice through it, okay? Alright, so now let's just do a couple of examples and we'll be done. This is basically what I just went over, okay? Now, on your own, describe each cross-section. Here, I've taken this kind of donut-looking shape and I'm doing a horizontal cross-section. What is that going to look like? Well, we're going to have a circle on an outside, and then there is that hole in the middle. It basically looks like a two-dimensional donut. Here we took a vertical cross-section of a cone, and you can see since it went straight through the very tip of the cone, that is going to make a triangle. Now, if it hadn't gone right through the tip, it was a little more forward or back, it would have made a parabola. But since this one went right through that, we make a triangle. Okay, now we're going on to this. It looks like it's like a hexagonal shape with a, I believe that's a circle, and I'm trying to, no, it's a hexagon. Okay, so kind of like the donut, I'm going to have a big hexagon, and then inside we have a little hexagon. There you go. There's your shape. Okay, so then, same idea here. I'm taking this kind of triangular prism with the hole in the middle, but it's not a hole, it's another triangular prism. And we're doing a horizontal cross section. And we're going to get, we've got this bigger triangle here with the littler triangle on the middle. Okay, and on this one it's pretty easy to see that that is a rectangle. Sorry, let me try that again. So that's the general idea of this section, is all we're doing is looking at taking cross sections. So you need to do the assignments, the prompt, and that's just going to be a couple of pages. It'll go pretty fast. It's going to be a good refresher on finding area and finding volume. Now, if you don't know formulas, then just Google it, okay? Use your resources out there. If you do get stuck, let me know. Make sure you also watch the videos. They've got some really cool information. Thanks, guys. Have a good one.